Hello everybody. Today I'm going to be making copper and sulfuric acid from copper sulfate, this beautiful blue solution. So the copper sulfate is already dissolved in here. It's usually crystalline form, but it's dissolved. So I got this copper sulfate from some copper carbonate I had, and I neutralized the copper carbonate, with sulfuric acid. So it may sound pretty counterintuitive to make sulfuric acid from already used sulfuric acid, but I'm just gonna reprocess it into what it was before, copper and sulfuric acid. Although I'll have elemental copper and not copper carbonate, which is what I want. So the way I'm gonna do that today is electrolysis. I'm gonna set up an electrolysis cell, and we're gonna electrolyze the copper out and make some sulfuric acid. So I will bring you when I have the cell set up, and I'll show you how it works. Here is my setup. I have a car battery trickle charger. This outputs 24 volts, 350 milliamps. I have that going through the wire. Into the terminals, I have them wired up with some copper. Positive terminal going to my positive electrode, and negative terminal going to my negative electrode. For my electrodes, it'll focus, maybe. Okay, it doesn't really want to. But for my electrodes, I'm using a copper wire and a platinum electrode. I got this on Amazon, but you don't necessarily have to use platinum. You could use carbon, like a carbon rod from a battery or something like that. That works also. The only problem is that you'll have a bunch of carbon pieces and you'll have to filter your solution. But what it's doing right now is it's plating out the copper onto my copper electrode. And it's making sulfuric acid and some oxygen on my positive electrode, which looks really cool. This will probably take a long time to run, but as more and more of the copper sulfate gets used up, it'll get clear, and eventually it'll be pretty crystal clear, and that's when I'll know that the reaction is completed. So yeah, that's my setup right now, and it works. It's definitely not perfect. If anybody has any suggestions for a better power source, please leave them, because I'm not super good with electrolysis, but I understand it enough to do some basic things. So I will come back either when the sun is set or when the reaction is completed. I think it will take a little longer than that, so I'll come back with an update. I've been out of town for 2 days and I've left this going, and my copper electrode has definitely grown. It's gotten bigger, but I would have liked to see more progress over 2 days. I think the voltage is fine, but I wanted to get a little bit more power, so I'm gonna wire up another panel to it. I'm gonna wire it in parallel so that it gets around 700 milliamps as opposed to 350. And that should help speed things up a little bit. So I'm gonna do that. All right, it's now wired up. The wiring is absolutely atrocious by now, and if you're using higher currents, would definitely not be safe at all. I wouldn't want to leave this running for a long time because I'm sure it'll find a way to short itself out. So horrible wiring aside, it is going a little bit faster, which is good. More bubbles. So we're just gonna leave it be, and hopefully my electrode just continues to grow. Eventually it'll go clear, and then we'll have our acid. Nice. All right, progress report. It's been about 2 to 4 days since I started this. Don't exactly remember, but it's getting some good sun right now, so it's bubbling pretty nicely, and my electrode is collecting a lot of copper. So it's definitely working, definitely doing its job. And please don't short. Okay, I'll fix that. But it's doing what it's supposed to. It's getting on its way. That's good. Very good. Color's gotten a little less intense, I think. So pulling the blue out bit by bit. It's the next day, getting a lot of sun, and it is almost clear. We're close. We're getting some hydrogen formation on our anode, which means that it's not getting enough copper sulfate to reduce into copper, so it's making hydrogen instead. And it's working. I don't know how long it's gonna take to find a little bit of blue out, but it's doing its thing. Making a good bit of oxygen, some hydrogen too. Electrolysis is always fun to watch. Yeah. Well, I'll be back this time when it is fully clear, or if I run into a problem. I don't think I will. I think it'll clear up. Now it's the next day, and it finished. It's all nice and clear. My copper electrode's all covered in copper, and it's making hydrogen and oxygen. I'll get this cleaned up, and we'll see how acidic it is. After that, we're gonna boil it down, and we should have our sulfuric acid. Nice. I have my sulfuric acid mixture here. It's mainly water, but we'll measure its pH in a second. And here's my copper electrode. Has a lot of like copper fuzz on it pretty much, but it'll just break down into copper dust. But it's neat that I could take blue crystal like this one and get it to turn into a metal. Chemistry is just awesome. Let me get a pH strip and test this. All right, let's see. I need dip a stir bar in there, and there it is. Definitely acidic. I think it's about a 2, maybe close to a 1. Still, that's pretty good. So now all I need to do is boil this down and get some concentrated sulfuric acid. And then that should be our project finished. I'll also be washing this, getting as much copper dust off and just washing all the copper so I get all the like little acid residue out and all that. And then I'll put it with the rest of my copper. But yeah, this is pretty much my product. Just been running it, a nice clear solution, and my copper. So how am I doing this? Well, here's a model of my electrolysis cell. If this is my platinum electrode, positive, and this is my copper electrode, negative. So it's taking the copper sulfate in solution along with water, and it's making sulfuric acid, copper, and oxygen. So what we see here is we see the copper forming on this electrode. That'll be my copper. So copper is forming on this electrode because as you pass electrons through it, it does a reaction that doesn't normally happen. This only happens with energy. So electrons flow through here. The copper gets reduced here and plates onto it, falls off. The copper gets pulled out of solution here. Now at our positive electrode, you have our sulfuric acid being made and the oxygen bubbling out. So you'll get all these oxygen bubbles coming off, and that's taking water. So what it's really doing is it's taking copper sulfate and water, it's pulling the copper out and putting the hydrogen onto the sulfate. Then it's just getting rid of the O2. The reason it doesn't just dissolve the copper back is because sulfuric acid isn't strong enough to really do that without an oxidizer. So this is the gist of it. I might be wrong about some anode and cathode mechanics, but I'm not particularly learned in electrochemistry. I just do it sometimes because it's cool. But this is pretty much what it is. I can take energy and turn a pretty blue salt into destructive acid, which is very neat, very cool. And copper sulfate is also one of my favorite chemicals. So this whole thing is just great. The only thing is it's pretty slow based on how much power I'm giving it. So yeah, anyway, on to the rest of the video. I'm washing my copper, and only around that much came off the electrode. The rest of this is fairly solid. Just got some crystals on the outside and then pretty much solid copper on the inside. It did a really good job of electroplating a good bit of copper on here while the solution was concentrated. So that's very neat. Makes a lovely noise too. And now we start the boiling. I've had it heating for a bit, and it's reduced in volume by a lot, and it's also changed color slightly. Looks like something is starting to solidify out. Maybe some crystals. I think we're getting close to getting some pretty concentrated sulfuric acid. I'm wearing gloves because boiling sulfuric acid, well, not boiling sulfuric acid, but hot sulfuric acid is very scary and dissolves stuff like paper even. So it's not good to get on your skin. I have a pH strip right here. You see. Okay. The fumes aren't acidic, but if I get a drop of it, it will be. Yep, that should be reading a 1. Yep, that's a 1. Maybe a 2, but very concentrated acid right there. Probably not 100%, maybe 70 or something, because there's still water boiling out. But I'll know that it's there when the water stops boiling. I'm not really in any danger of boiling the sulfuric acid because it's only at around 400 degrees Fahrenheit, 206 for you Celsius guys. And I think sulfuric acid boils at over 300 degrees Celsius. So I should definitely be safe for not boiling it. But it will get all the water out and make it better. So we're getting on our way, we're getting closer. It's probably not going to be completely pure, it's going to be a little dirty by the end, but we'll have made it. I've let it sit for longer, and it's now, the liquid is around 320 degrees and has stopped bubbling, which means that it is now got all the water out of it, and we should have just the sulfuric acid. So I'm going to turn off the heat. It is discolored and a little goopy in there, but should have our acid now, and I can test that by getting a little bit in this dropper. And putting it on a flake of sodium hydroxide that I have. It's definitely bubbling. It's not particularly violent because of how concentrated it is. It's having a hard time dissolving it. But if I add a bit of water, that's empty. If I were to add some water, it would proceed much more rapidly. But it's neutralizing the sodium hydroxide, so that's good. Now, if you haven't, would definitely be the time to put on some protective equipment, gloves and eye pro. You definitely do not want this in your eyes. And now I'm gonna transfer it into a smaller beaker. This is a little cold, so I might sit on here to warm up so I don't shatter it. But yeah, that should be our acid. This is our final result. About 10 mils of fairly concentrated sulfuric acid. It is a little bit dirty, but this should work fine for either making nitric acid or some other experiment that you'd need a strong oxidizer for. It's not perfect. Nitric acid is a stronger oxidizer than it, but you can use it to make nitric acid and all sorts of fun stuff. And it's also fairly viscous. Don't know how well that comes across on camera, but it is almost like diluted syrup, which is very interesting. But yeah, this is our end product. We took blue copper salt, copper sulfate, this stuff, and turned into these: copper metal and sulfuric acid. I hope you enjoyed. If you liked the video, please leave a comment. If you have anything to say, please leave a comment. And if you think that I earned it, consider subscribing. But thanks for watching, and hope you had fun, because I did.